do that. What's the first thing we have to do to solve this thing? Or start finding the parameters? Yeah, we have to combine the parallel portion, and we call that thing LEQ. Rules for finding inductors, or total inductors in parallel. Oh, it's reciprocate. So we have 8 millihenry inductor in parallel to 20 millihenry inductor. To find the LEQ, we must reciprocate, and if you did that properly, the answer should be smaller than the smallest, right? Yes! So it better be smaller than 8 millihenries. So our LEQ, who's got that answer? Who's got that answer? Oh, Mr. Strickland. Yes, what is it?
Is it 5.71 millimeters?
I don't know, is it? Does everyone else agree with that?
Yes, sir.
Do I agree with that? Let's see. I'm sure I do. Yes, I have 5.71 millimeters. See, I did this stuff too. I don't just make up things. Got it right. Yeah! Good. Good job. What's a good idea for those that might still not quite have it down, or just to be sure that you keep everything straight? What's a good idea here? Redraw it, so you don't get lost. It's just like series parallel resistor circuits, isn't it? It's the same thing. It's BO1 stuff now. So I'll redraw it real quick here. Because this represents the what? The LEQ, or equivalent inductance. What do I do with this one? Just leave it alone. L1, just move it over. It's 4 millihenry. LEQ, we just found it, 5.71 millihenry. How do we find total inductance now in series? Just add it. So that would be our L total, wouldn't it?
Yes, sir.
What's the answer, Mr. Feller? 9.71 millihenry. How are we doing so far?
Yes, sir.
It's easy stuff, isn't it?
Yes, sir.
All right. Could we have, or you, last night when you were working on this, could you just have gone ahead and found all the inductive reactances first? Yeah, you could, because you have enough information, don't you? 2 pi is a constant, we have the frequency, and you have this, or don't you?
Sure.
You do, because it's individual. If you want to find XL1, you just use L1 here. And L2 and L3 respectively. So you could have done that first, doesn't matter. Doesn't matter. So XL1, now we have to apply this formula in case you forgot. Hey, just do this. Make a subscript. XL1 equals 2 pi times frequency times OL1. So you get XL1. So who has that answer? Make everybody proud. Okay, Mr. Fry. XL1.
427.27 ohms.
You said 427.27 ohms. How'd that sound?
Yes, sir.
Pretty much what I got. 427.26. Hey, close enough. And let me tell you this, speaking of being close enough, make sure you calculate these parameters on exam tomorrow, choose the closest answer. Because they all don't come out like exactly perfect. So if you do it right, and it's okay. If you do it right, you'll be able to choose the right answer, won't you? As I told you back in VEO1, if you have 4 distractors, you're not going to have to flip a 4-sided die to figure out, because they're only like 1/10 of a volt off or something, all 4 of them. No, it's not going to be like that. There'll be enough disparity between. If you do correctly, it'll be okay. XL2, answer. Who has the answer? Mr. McCarter.
854.51 ohms.
How's that sound? 854.51 ohms. I hear no grumbling, so that must be good. Hiramoto, yes or no?
Yes, sir.
Good? Okay. How about XL3, Mr. Hiramoto?
XL3, 2.14 XL.
All right, you like a lot. Now we can go, hey, we can find XLEQ. We can do that. We can find XL total. There's a couple different paths. Let's go this path. XL total, if we treat ohms like ohms, but here's something. We might want to find XLEQ first, huh? Just to make sure we don't screw it up. Or, guess what else you could do? You know L total, don't you? Is that another method? It is. It's another method. So if we just go straight up and use our individual inductive reactances to do that, well, we need to go find XLEQ. There's a couple of ways to do that too, isn't there? Couldn't we do like this? Could we use LEQ to find XLEQ? Yes. Or XL2 and XL3, because that's what's in parallel. How do we treat ohms in parallel? Reciprocate. Everybody see the different ways we can find the same answer? Okay. So, any one of those methods are going to work. So our XLEQ is what, Mr. Goss?
609.91 ohms.
609.91 ohms. Close enough. I got 610.67. What? There's going to be a very small disparity. Why? Because of the different methods you could use, right? And we round and all that stuff. So yeah, as long as you're right there close, you're going to be okay. So I'd accept that. So take your pick. Use the LEQ to find XLEQ. We could have did that, or hey, treat ohms like ohms. So XL total. You don't just add these up, do you? No, because it's a series parallel. So what you can do by redrawing XL2 and 3. Did we find that? That's this, isn't it? That's the 609.91 ohms. What is XL1? Right here, isn't it? Yeah, 427.27 ohms. That's the XL1. So if you redraw and you do like this, you have XLEQ. Isn't that a way to find XL total? XLEQ plus XL1, because now they're in series and we add ohms in series? Yeah, that's right.
SLT, I have 1.04 kilo.
Yes. I was trying to find them like, who's it? Yeah, 1.04K. Good job. One final thing here. I total. We can use Ohm's law, can we? Yes. So we can take, hey, we're trying to find I total. What's the E we have to use? Right here, right? Yeah, the 40 volts peak to peak, so the V sub A, the 40 volts, divided by the ohms. Look, I just wrote omega now, didn't I? I'm not doing the XR, omega, what else am I missing? Zeta. Not doing that no more. I'm just going to put omega in there now. Because we all should know by now what that means and what it refers to. It's all opposition. So 40 divided by, what is this? What do I have to use? What is it? It's XL total. So 40 divided by 1.04K should give us the total current in this circuit. And, yeah, Mr. McCarter, what's the answer?
38.46 milliamps peak to peak.
You said 38?
Sir, 38.46.
Okay, yeah. 38.46 milliamps, and it is peak to peak since that's the input. It is a peak to peak value.